So welcome to lesson 3.8. So now we're going to solve some percentage problems. So yesterday we were talking about rates, I guess the last lesson we were talking about rates. So for this one we're going to talk about percentages and how we can use those to solve problems. And again, they're still equations because they have equal signs. So for a little warm-up here, we're going to take a look at a couple of questions here. So what does the word percent mean? Right? So if we actually look at the word percent, that literally means, right, it's a ratio, right? Cent means 100. So this is a ratio out of 100, right? So per 100. Okay. When is percent used outside of math class? Well, some ideas might be when you want to figure out your grade on a test. Discount at a store. Right? When something's like 25% off. You're figuring out tax, like HST, right? It's 13%. In sports, sometimes they give statistics, right, in percentages. And then like in marketing and stuff, you can look up like stocks, right, how much something rose or fell, right, a certain percent. There's lots of examples of how percent's used outside of a math class. Those are just a few. Okay, so if we take a look at this table here, we're just going to quickly refresh our memories of how we convert between fractions, decimals, and percentages. Okay, so this first one, they gave us the percent, it's 155%. How do we get it into a decimal? Well, whenever we go from percent to decimal, we divide by 100. So that's going to give us 1.55. And then how do we write this as a reduced fraction? Well, we know it means 155 out of 100. So again, we need a reduced fraction. Let's divide those by the biggest numbers that we can. If we divide them by 5, we get 31 out of 20. Okay, so next one, we have the fraction. How do we get it into a decimal? Well, a fraction literally means 9, in this case, divided by 16. So we could just do that on our calculator and we get 0.5625. Now if we have the decimal and we want to go to a percent, we have to multiply by 100. So that's going to give us 56.25%. We can multiply by 100, or we can, if you remember, move the decimal 2 places to the right. It would also work with this one above, the percent, the 155%. There is technically a decimal right here, so we would move it 1-2 places to the left. Okay, so what happens if we start with decimal form? Well, we could easily get the percent, right? We could move the decimal 2 places to the right, or multiply by 100, and we're going to get 6%. Now, we could also get our reduced fraction, right? This means 6 out of 100. And if we reduce here, we divide both by 2, we can get 3 out of 50. And the last one here, they gave us this percent. Well, 43.2, it says percent. Please don't confuse that with the decimal. Yes, it has a decimal in it, but it's a percent, right? It has this unit. So if we want to go from this percent to a decimal, we're going to have to divide by 100 or move the decimal point 2 places to the left. Either one is going to give us 0.432. And then if we take this, remember percent means over 100, and then we want to reduce this, so I get 54 over 125. Oops, sorry, this is out of 1,000. Ooh, forgot this one too, out of 1,000. Remember, when you have a number bigger than 100, you have to put it over 1,000. Okay? All right. So, let me check that first one again. I feel like my first one might be wrong. Yeah, this should be over 200. I apologize. My mistake. Okay. No, I was right the first time. Wow, sorry, it's early. This one should also be over 100, so this one's wrong. Let's fix this one. So 400 and, because, no wait, oh boy, oh my gosh, I'm confusing myself. This first one is 155 over 100 because it's 155%. It's more than 100%. Excuse me. My decimal is 1.55, right? So that means I have one whole and then 55 out of 100. This last one here is only 43.2%, right? So this one, we have to put it over 1,000, because if we put it over 100, then that would mean that it's like 432%. So I was actually right on this one. Just a little slow this morning. Okay. Moving on. So in her math class, Samantha's 2 most recent quiz grades are 29 out of 35 and 22 out of 26. Which quiz grade represents the better score? So just looking at these two sets of numbers doesn't really tell us much. It makes more sense if we convert them into their percents. So she got 29 out of 35 and she got 22 out of 26. So remember, if you want to convert into a percent, we just divide the top, the numerator, divided by the denominator, and then multiply by 100%. So in this case, we would end up with 82.9%, and in this one, we end up with 84.6%. So this one would be her better grade. Okay, so we're going to go a quick review through percent. So remember, percent is a ratio between two quantities where the second quantity is always 100. So 84% means 84 over 100, or 0.84. You need to have a good working knowledge of percents, not only for success in our math course, but also because percents are used in so many areas of our lives, like we said, outside of school, in sports statistics, taxes, wage increases, sales commission. There's so many different times that you're going to see percent in your life, so understanding percent and how it works is pretty important. So when we're finding percent, it actually does involve working with equivalent fractions. Many percent problems are easily handled by just solving a proportion. So like we were doing in our last lesson, if we have the part over the total, we know that the percent is over 100. So a lot of the times thinking of the ratio part over total as is over of. The whole is often preceded by the word of in the problem, right? Like 25% of, okay? So is over of is 100, or is percent over 100. So the part or the percentage often precedes the word is in the problem, right? So we are going to try and use some of these terms to help us solve some problems here. So for the first example here, we want to answer each by setting up an appropriate proportion and then solving for our unknown. So if we round each to the nearest tenth where appropriate. Okay. So what number is 18% of 200? Okay. So these ones, we want to do 18% of 200. So these ones are pretty simple ones. So if we can remember, right, from above, our is over of is a percent over 100. So I'm going to write that over here. Is over of is percent over 100. So what number is 18%, right? So 18 over 200 equals the percent over 100. So we can try this here. Oh, I think I did this wrong. Wait. Something is wrong here. Hold on. We're going to ignore this for right now. We're going to do this the easy way, actually. So what number is 18% of 200? There's a really easy way to do this. So we can change 18% to a decimal, right? move the decimal place over 2. So we get 0.18. And then of means multiply by 200. Right? 0.18 times 200 is 36. So 36 is 18% of 200. That's a lot easier way than writing proportions. Then for part B, 42 is what percent of 98? Well, 42 over 98, just like we got a mark on a test, right? Times it by 100, and that's going to give us 42.9%. Part C, we've got 6% of 24,000. So again, move your decimal 2 places over. So we've got 0.06 times 24,000, and you end up with 14,400. And then the last one here, 12% of what number is 1,044. So this one, I would actually probably set up what this is an of way. So I know that 12 out of 100, right, that's 12%, of what number is 1,044. So I know that 12% gives me this 1,044, but I don't know what that actual total number is. So in this one, I'm going to do that reciprocal. Okay, and then I'm going to multiply both sides by 1,044. Sorry, I'm writing this poorly. So 1,044 times 100 and then divided by 12, we get 8,700. Okay. All right, so the rest of these are word problem ones, kind of more like real life examples that we would see outside of just math class. So Tanisha is about to sell her house for $315,000. Her real estate broker will expect to receive a 6% commission for all of her hard work in finding Tanisha a buyer for her house. How much money will the real estate broker expect to be paid once Tanisha's home is sold? So what they're asking us for is 6% of this $315,000. So we could let X represent the amount in dollars the broker gets paid. So we know that Tanisha has to pay this 6%, right? So 6 out of 100, and that equals the amount that we're looking for out of the 315,000. So again, we can multiply both sides by 315,000, and we get 18,900. So therefore, the broker gets $18,900. Now, another easy way to do this would be to just change that 6% to a decimal and multiply it by 315,000. And we still get that same answer of 18,900. Okay, so whichever way you like better. Okay, so example 3 here, Quinn decides to raise all the prices in his store by 4%. What's the new price of an $8.50 or $8.25 item after the 4% increase? What's the final cost after the 13% sales tax is added on? Okay, so I'm just going to use X. Let X represent the increased price. The increase price in dollars, and then I'm gonna also need the final cost one, so I'm also gonna say and Y represent the final price in dollars. So right now he's raising all of his prices in his store by 4%. So we would normally have, like, his normal price is like the 100%, right? So in this case, we'd have to think of it like 100% plus 4% equals 104%. So I would do the 104 over 100, right? Because if we just do 4%, it's not going to work. And then that's X over, and then the item that we're looking for is $8.25. Because if we just did 4, that would be like we would just are looking for 4% of the $8.25, but we're not. We're looking to figure out how much this would be if we increase it by 4%. So that's why we do the 100 plus the 4 to give us that 104%. So instead of paying $8.25, we're paying that plus another 4%. So in this case, right, we're going to multiply both sides by $8.25. And 825 times 104 divided by 100 gives us $8.58. So that would be the new price of the item. And then we want to add the tax. So an easy way to add sales tax, right, 13% HST, we can just do 1.13 times the amount. Okay, that's probably the easiest way to ever add HST if they just want a final cost. And that gives us $9.70. Okay, we could also have set this up like a ratio. It would be the same idea. It'd be 113 over 100 equals X over 858. So whichever way you wanted to set it up, but honestly, I think just multiply by 1.13 is pretty easy. So then we could say, therefore, the final price is $9.70. Okay. So next, Discount Dave's is having an end of summer clearance sale. All items are 60% off. What is the sale price of a flat screen TV normally priced at $3,499? What's the final cost after the 13% sales tax is added on? So when you get questions where it says something is like a percent off, what we actually care about is how much you have to pay still. So if something is 60% off, that means that we're still paying 40% of the original price. That's going to be a way easier way to solve this. So if we did 40% out of the 100% that we normally pay, that would equal our sale price over how much the TV originally cost. So if we were to multiply both sides by the $34.99, we could figure out our sale price. Right, $3,499 times 40 divided by 100 gives us $1,399.60. And then again, to figure out your tax, just multiply by 1.13, right? The sales tax is 13%, so multiply that by 1.13, and we end up with $1,581.55. Therefore, final cost of TV is $1,581.55. Okay. All right, and we just have 2 more examples here. So Harleen is shopping at the mall. She notices a shirt for 40% off. How much did the shirt cost if she received a $17.68 discount? Okay, so we're going to let X represent the original price of the shirt in dollars. Okay, so we know that she got 40% off, right? So 40 out of 100. And we know that the discount was $17.68. But we don't know what that original price was. So in this case, even though it said 40% off, we don't care about how much we are actually paying, right? We care about what the original total was. So I wouldn't do this question like I did the last one. That's why we have the 40 over 100. So this one we could just do the reciprocal. And then we could multiply both sides by that denominator. Oops. So 1768 times 100 and then divided by 40, we get 44.20. So therefore, the shirt originally cost $44.20. That's an expensive shirt. Okay, so last one here. Sheila claims that if you increase a number by 10%, then decrease the result by 10%, you're right back where you started. Show that Sheila is incorrect by using a specific numerical example. So in this case, we can pick any number. So I'm just going to choose 50. Okay. So we're going to let X represent the increased value. So in this case, we'd have 50 over X equals 100% over 100% plus 10%. Right, because in this example, I picked 50, right? You could have picked any number. You could have picked 10, you could have picked 5. I'm just picking 50, okay? So we want to take a look at here, right? 50 would be like our normal total amount. But she's saying that if we increase it by 10%, right? So that's my bottom here, right? We need to figure out what this number is. If we increase 50 by 10%, okay? So, 50 over X is 100 over 110. So again, we need to do reciprocal. Multiply both sides by 50. And X is 55. Okay, so if I increase 50 by 10%, I get 55. Then she's saying that if we decrease our result, so that answer I got, 55, by 10%, we're right back where we started. So we're going to say now we're decreasing by 10%. So we're going to let Y, represent the decreased value. Okay, so we know we're starting out with 55, and we want to know what that decreased value is, so that's our Y. Right, so now 55 becomes our original number, and then we're going to decrease it by 10. Sorry, these are percents. Right, so we've got 55 over Y equals 100 over 90. Again, we need to do the reciprocal and then multiply both sides by 55. So 90 times 55 divided by 100 gives us 49.5. So it said to show she's incorrect. Well, we can see that she's definitely incorrect because she's saying if we started a number, increase it by 10, then decrease it by 10, we're right back where we started, which means we should be at 50, but we're not. We're at 49.5. So once we did that, so we could say therefore she is incorrect because original value was 50 and after increasing by 10%, then decreasing by 10%, we get 49.5. And we all know that 49.5 does not equal 50. Okay. Okay, so this is the end of Unit 3. Make sure that you try the homework questions, check your answers, and ask any questions you might have. And once you're done that, you should try the test review, as our test will be coming up shortly after.